Yeah, see now. So during our previous session, we have we we discussed in detail the idea of ordinary obtaining solutions to ordinary differential equations of first order, and we have done problems. We answered some problems. We practiced some problems from the gate. So there, if we quickly look at that, there is separable equation. We talked about separable equation. Then we talked about homogeneous equation, and then equations that are reducible to homogeneous equation type. So that also we have discussed. Then Leibniz linear equation is one thing, and subsequently Bernoulli's equation, which is a nonlinear one, that is reducible to this Leibniz equation. That part also we have dealt with, and then exact differential equations we have seen, and the idea of integrating factors. I mean, how to deal with the non-exactness. That part also we have discussed. We have done good number of problems on that one, and subsequently grouping of terms. On that day I closed this one with this one, because on grouping of terms very less number of problems are there. So as part of the sharing the material, I have kept this slide, and in fact I have shared that one in the drive also. Okay, now the other one is most of the questions in ODE, first order ODE and second order ODE, that is enough for you. So the second order here also, first order we dealt with both linear and non-linear, while in case of higher order means second order we focus more on second order equations. In that one, we need to look at homogeneous and non-homogeneous things. So when you look at higher order equations, higher order ODE, here higher order means, here higher order we mean we are focusing on second order only. So here, that is gate question, problems in gate comes from most of the time second order. That is why we are focusing on this one. And that too, we are very particular about all the questions are linear ones. Higher order linear ODE. This is only linear. Higher order linear ODE. So some examples we will see what are higher order linear ODE we mean. See here, if you look at, for example, see the convention we follow here is, when we are talking about ODE, there are two variables which we are in fact dealing with. One is called, one we most of the time represent by X and the other by Y. This X is considered to be always during our discussion, it is independent variable, and Y is dependent variable, and Y is dependent variable. Then see, we can talk about dy dx, because we are, and we can talk about d square y by dx square. These are all ordinary derivatives. This is second order derivative. Third one is d cube y by dx cube. This is etc. Because we are focusing on only second order, by keeping gate questions in view, only these two things will come into picture. So these things can in short be written in the following way. In short be written in the following way. So we write d by dx here in short as d. Then d square by dx square as d square. If you go for a little higher order things, then we have d cube by dx cube is written as capital D cube. So this is our notation. This is our notation. So how can we represent, then how can we represent dy by dx? Because this dy by dx, see here, this part is written as d. We write this as dy simply. Similarly, d square y by dx square we write as d square y. Similarly, d cube y by dx cube is represented as d cube y. So now we have some examples of differential equations. Our first example is d square minus 5d plus 6y. I will explain what we mean by this one, is equal to 0. This is our first example. What is the meaning of this one? We are writing in terms of d here. So what is the meaning of that one? The meaning of that one is you can rewrite this as d square y minus 5dy plus 6y is equal to 0. One can write like this is the meaning actually. From here we are going here in short. But what is this? The second one. The second one we mean it is d square by dx square. Small capital D square means, and you have y here, minus d means d by dx, capital D means you have y here, 6y is equal to 0. So this in short can be written like this, and further the above can be written like this. And now see, this is our first example. This is our first example. This is our first example. Now we go for the second example. The second example is the second example is say for example you take this one d square minus 2d plus 1 into y is equal to say e power 3x. That is our second example. So what is the meaning of this one? Because we need to look at the shortcuts. That's why I'm giving here. So what we mean by this one? We mean this we mean d square y minus 2 dy plus y is equal to e power 3x. This is the meaning. So further this can be viewed as d square by dx square upon y minus 2d by dx upon y, acting upon I mean y is equal to e power 3x. This is the one. So this is written like this, and this is further, this can be further viewed as this. So this is our second example. Now look at the third example. We will go for the third example. The third example is we are looking at the third example. For example, the third one is we are taking the third one as say d square minus x into d, say plus x square acting upon y is equal to 0. See something, this is different. How that is, this can be written as directly I write in terms of d square by d by dx way. If we write in d by dx way, this is nothing but d square y by dx square minus x into dy dx plus x square into y is equal to 0. This is our, we mean. See, this can be written like this. In a similar way, we can take one more example. There are only four examples which I would like to give here. So if you look at the fourth example, one can take the fourth example as d square plus xd sin x y is equal to say e power x. This is another equation. How this can be written? This can be written in terms of d by dx way. That is what I am saying. In d by dx way, this can be written as d square y by dx square plus x dy dx plus sin x into y. See here, sin x into y is equal to e power x. So this can be written in the above way. So these are the four examples. Today we will discuss about this. If once we discuss about these four examples, gate topics in ODE will be completely covered. So for example, if you take the first example, how the first example differs from the second example? In the first example, first notice that the coefficients here, see the coefficient of d square, the quotient of d, you look at that. So quotient of d square is 1 here, quotient of d is 5 here, and 6 is a constant. So this is called a linear equation with constant quotients, and in the right hand side it is 0. So it is called a homogeneous linear second order ODE with constant quotients. When it comes to the second example, here also the quotient of d square is 1, the quotient of d is -2, and here also a constant is there, but in the right hand side is not 0. So this is called a linear second order ODE with constant quotients, and it is a non-homogeneous equation because you have the right hand side a function which is not 0, e power 3x is there. Then we will go to the third example. The third example, you see here, if you look at the third example, there the quotient of d square is 1, fine. But the quotient of d is not a constant, it is -x. X means independent variable here. So the quotient of d, the derivative involves x, independent variable. And of course here also we have in place of constant a function involving x is there. And on the other hand, in the right hand side you have 0. So this is a non-homogeneous equation which is a linear ordinary differential equation with variable quotients. Why? You have this as variable, this as variable. Of course, for d square you have 1. That is not the question. So we have this example is a linear homogeneous second order ordinary differential equation with the variable quotients. Then if you look at the last example, here the quotient of d square is okay, it is one constant. On the other hand, the quotient of d is x, it is a variable thing, and you have in this place sin x. So this is also a linear equation with variable quotients, and on the other hand, in the right hand side you do not have 0 here, some non-zero function is there. That is why it is a non-homogeneous linear ordinary differential equation which is of second order with variable quotients. So this is what today we will look at. Okay, so if you look at that one, if you go to this, so about here, so we are focusing on second order ODE. So when you look at this one, I clearly explained the notation here about capital D square, etc. And then we talked about with constant quotients and with variable quotients. See, I have divided this whole thing divided into two parts with constant quotients and with variable quotients. If it is constant quotients, we have homogeneous and non-homogeneous. There are two things here. So when it comes to homogeneous, general solution of homogeneous equation and general solution of non-homogeneous equation are there here. And when it comes to the variable quotients, you have there also homogeneous, non-homogeneous with variable quotients, it was there. So we have seen all those things using examples here, using the examples here. Those 4 cases we are about to discuss. Fine. Now see, Yeah. So if you look at this slide with constant quotients, it is a homogeneous part. Probably we might have see a simple equation I have taken. AD square plus BD plus C into Y is 0. So for example, I will go to the examples here. If we go to examples here, if we go to examples here, the first example, if you look at d square minus 5d plus 6 is y is equal to 0. So, okay, we start with that one. We start with that one. So, d square minus 5d plus 6 acting upon y is equal to 0. So, this part we represent by f of d. It is a function of d. What we do is that we try to factorize that. That is, we try to find, this is a homogeneous equation with constant quotients. So something called auxiliary equation we are creating. Auxiliary equation. What is, when we are saying auxiliary equation, you have auxiliary equation is Fm is equal to 0. M is some number that to be determined. So f of m is equal to 0. That is called auxiliary equation. See, f of d means here d square minus 5d plus 6. F of m means what? F of m means, here f of m means m square minus 5m plus 6 is equal to 0. So, if you solve this one, this is a quadratic equation. If we solve this one, you can easily minus b plus or minus square root of b square minus 5 whole square, that is 25 minus 4ac. So you have 4 into 6, 24 by 2a. 2a is 2 here. See here, usually when we talk about quadratic equations, how we write? We write am square plus bm plus c is equal to 0. This is called quadratic equation. What is the formula for roots? The formula for roots is m is equal to minus b plus or minus square root of b square minus 4ac by 2a. This is the formula. So in our present context, our a value is 1, b value is minus 5 and c value is 6. So based on that one, we got this. So this is nothing but 5 plus or minus 1 by 2. So what are the roots here? 6 by 2, 4 by 2, 6 by 2 is 3, 4 by 2 is 2. So 2 comma 3 are the roots. 2 comma 3 are the roots. And notice one thing. This is very important. For this equation, we found roots as 2 comma 3. So you can write this whole equation as, this expression part as m minus 2 into m minus 3, their roots is equal to 0. M minus 2, 2. So the given differential equation in fact can also be written if required, because if required in the next slide we want this type of notation sometimes. So you can write d square minus 5d, this is given one, plus 6 acting upon y is equal to 0. You can write as d minus 2, d minus 3 acting on y is 0. You can write like that. So we found the roots now. We found the roots now. So once we found the roots, see for a quadratic equation, here if you look at the quadratic equation here, this equation am square plus bm plus c is equal to 0. Roots can be distinct real numbers, or roots can be, there will be two roots because it's a quadratic equation, and they may be same root for same root you may have, or complex roots. Complex means if some a plus ib form, alpha plus I beta form. If alpha plus I beta is there, alpha minus I beta is also a root of that equation. This we know. So what are the possible roots for possible choices of roots? Possibilities here. When we are dealing with am square plus bm plus c is equal to 0, we have three choices, three possibilities. We may have two roots m1 comma m2. They are distinct. Or we may have same root m comma m. So this is called a double root. The other one is alpha plus complex roots, alpha plus I beta and alpha minus I beta. They are the possibilities. So to find a solution to the homogeneous equation, where is the equation here? The equation is here. AD square plus BD plus C constant coefficients acting upon y is equal to 0. I am talking about this one. For this one, the general solution is that is y of x is equal to, if it is the first case, m1 and m2 are different roots, then real numbers, then ae power m1x plus be power m2x is the solution here. General solution, we call it GS, general solution. Similarly, if m and m, that if you have a double root, same root, then yx is same root, I mean. You have to write a plus bx into two arbitrary constants, because we are dealing with second order equations. We have two arbitrary constants. They are namely a capital A and capital B. So you have e power mx. The third case, the third case is they are complex roots, that is alpha plus or minus beta. So how that can be written? Y of x is equal to e power real part times x into arbitrary constant a cos beta, imaginary part of that complex number, plus b into sin beta x. This is the answer. So we need to remember that for these three cases, where are the three cases here? The three cases are here. The three cases are here. The three cases are here. So this is case 1, this is case 2, this is case 3. You look at that, in that context, we have here the answers for all the cases. So this is for C1, case 1, C2, same root, double root, that is m. The third one is complex roots, C3. So this is very important thing. That is what I have given. That is what I have given in this slide. In this slide, which slide? Yeah, if you look at this. Yeah. So this is the slide. See here. I have clearly mentioned about the complex roots, how the solution looks like. Okay. Now see, this is the slide I have explained. So What I mean to say here is that what we need to remember is that we are given an equation like this: f of d apply acting on y is 0. Then what we need to find a solution? Solution means what is y? This is the question. Simply you solve f of m is equal to 0. This is a quadratic equation. There are three cases. If they are distinct, real, you can say like this. Same root, real, you can say like this. Complex, you can say like this. Based on these things, we can give the answer. That's what we have said. Okay. So, for example, we have seen the second example here. If you look at the second example here, that is d square minus 2d plus 1 acting on y. So, d square minus 2d plus 1 acting on y, we mean d square minus 2d plus 1 acting on y is 0. If you want solution, what is y? Y solution means y. See, solution, there is another name in differential equation. Y is also known as integral. Integral and solution are one and same. For a differential equation, if they ask integral, what is the integral? Meaning is that what is the solution? Solution and integral are one and same. So, for this one, you have, what is the auxiliary equation here? Auxiliary equation is m square minus 2m plus 1 is equal to 0. Readily, the left hand side can be realized as m minus 1 whole square is equal to 0. So here m is equal to 1 comma 1 here. So there are same roots we have. There are same roots here, same real roots. So the solution is, or the integral is, a plus, a is a constant, b is another constant, into x e power, whatever is m is 1 there, 1 into x. So this will be the general solution. General solution means, for a you can give 0, for b you can give 1. For a you can give 1, for b you can give 0. For a you can give 1, for b you can give 1. Like that, what I mean to say, you can generate many solutions. So that is called a general solution. Similarly, complex case can be seen when we are doing the problems, gate problems. You can see that one. Now see, we go for I mean the non-homogeneous part. What is non-homogeneous part here? The non-homogeneous part example with constant quotients is given here. Third example. Not thirds, I think second, sorry. Second, e power 3x is there. So the right hand side is there. So what I mean to say is that when we have something like this, that is, you have a d square plus b d plus c acting on y, is instead of 0, you have some function of x. You have some function of x. So this is known as a non-homogeneous equation. Non-homogeneous equation with constant quotients, linear equation with constant quotients. So see here, how many, any equation has terms. How many terms this has? In order to know the terms, you need to write like this: ad square y plus bdy plus cy is equal to q of x. How many terms are there here? The number of terms here, we look at how many terms are there. This is one term, this is the second term, this is the third term, this is fourth term. This equation has four terms. This term involves y, this term involves y, this term also involves y. While this term involves y as a second order derivative. This term involves y as a first order derivative. This term only has y. On the other hand, this right hand side is free from y. Is free from y. So the one that is free from y we write in the right hand side. That is a function of 2x. So what is the strategy for such? This equation is called non-homogeneous equation. For this equation also we need to find a solution. So how to find a solution here? The solution we mean what is y? If this is given, what is y? That is the question. So first step is that we need to solve. First step is that we need to solve AD square plus BD plus C y is equal to 0. This is called homogeneous part. Associated homogeneous equation will solve. So that homogeneous part we write by YH. YH is also known as complementary function. Complementary function CF. Homogeneous homogeneous solution to the homogeneous part. Solution to the homogeneous part. And then we talk about another thing called particular integral, PI. Integral or solution are one and same, I told. Because we are dealing with non-homogeneous thing, particular integral or particular solution we need to. So once CF, that is, what is the CF? CF is the general solution of the homogeneous equation. So the general solution of the non-homogeneous equation of y is CF plus PI. So far we have seen how this CF can be found, and now how to find PI, that is particular integral, we need to see. So for that you have already an idea
Sir, you have stopped presenting, sir. Hello.
Hello, sir.
Hello, what is going on? Hey, can we leave? Vinay,
I don't know, Ra. Sir is not responding.
we are seniors, bro. Seniors went now.
I
If
don't
seniors
know.
are we can leave. Come, we leave off.
Sir is still in call. He didn't leave the call. But
What, bro?
sir stopped presenting. I don't know. Hello, sir.
But recording did not stop, right?
Yeah, recording did not stop. But sir is still in call.
Hello, sir. We can't hear.
Sir,
Yeah.
Hello,
he's
sir.
muted. Yes, he has muted the mic. He didn't switch on his mic. Hello, sir. You have stopped presenting, sir. We can't hear you.
Let's message, sir.
If you look at this question, y double dash plus py dash plus qy is equal to 0, and we are asked to find the values of p and q. So the roots here, right, y double dash plus py plus q is equal to 0. He is saying that for this equation, we have the roots as the solution as c1 e power minus x plus c2 e power minus 3x. c1 e power minus x plus c2 e power minus 3x. c2 e power minus 3x. Yeah, right. c2 e power minus 3x. So this is, now see, so if you find roots, what will be the roots? That is what we are saying. For this one, you can go back, the auxiliary equation becomes, okay, so the roots here are m1 is minus 1, m2 is minus 3. So m minus of minus 1 into m minus of minus 3 is equal to 0. So this is m plus 1 into m plus 3 is equal to 0. We have therefore m square plus 3m, okay, not 3m, it is 4m plus 3 is equal to 0. So what will be our differential equation? Our differential equation is d square plus 4d plus 3 acting on y is 0. So p is 4, q is 3. P is 4, q is 3. So the choice is there, I think, here. P is 4, q is 3, C is the answer. Now, which of the following is a solution of the differential equation? Y double dash plus py dash plus q plus 1 into y is equal to 0. So you cannot have here x square. Okay. Which of the following is, because is it connected to A and B? Yeah, right, because both are connected here. So 4 and 3. 4 comma 3, we have found P as 4, Q as 3, right? So our in the part B, he is talking about y double dash plus py dash plus q plus 1 into y. Okay. So q plus 1 into y. So we have d square plus 4d, q plus 1 is 4 again, y is equal to 0. So for this one, the auxiliary equation is, m square plus 4m plus 4 is equal to 0. This can easily be realized as m plus 2 whole square is equal to 0. M plus 2 whole square is equal to 0. So we have solution as y is equal to a plus bx into e power, here m is minus 2, minus 2, minus 2, minus 2, minus 2. So minus 2x. So this you can rewrite as a e power minus 2x plus bx e power minus 2x, bx e power minus 2x. So what do we have here? Yeah, x e power minus 2x is the answer. C is the answer because you have what are the possible solutions here? The possible solutions are okay, e power minus 2x, x e power minus 2x. So in this, in the choices, x e power minus 2x is there, so that will be the right answer. That will be the right answer. Now come to the seventh question. Seventh question is, go to the eighth question. Yeah, eighth question. Fine. If it is eighth question, so you have again y double dash plus 4y dash plus 3y is equal to 3e power 2x. Okay. If you go to the eighth question, what is our differential equation here? 4 plus 3. 4 plus 3. So y double dash 4 plus 3. Y double dash plus 4y plus 3 is equal to 3e power 2x. I mean here 3e power 2x. You have here y dash, here y. How can we write this? This can be written as d square plus 4d plus 3 acting on y is equal to 3e power 2x. 3e power 2x. So for this, the complementary function, if you look at this part, homogeneous part, you look at this, what is the auxiliary equation here? M square plus 4m plus 3 is equal to 0. Okay. So this can be factored easily as m plus 3 into m plus 1 is equal to 0. So we have m as minus 3 minus 1. So therefore, what is the complementary function here? That is yh, a power minus 3x plus b e power minus x. And now the particular integral. The particular integral here is yp is equal to, okay, yp is equal to, you have, or you can directly write like this. One can directly write like this, 1 by d square plus 4d plus 3, d square plus 4d plus 3 acting on 3 power 2x. So I already told this, you simply put in the denominator that 2 value. So you have 3 by 2 square plus 4 into 2 plus 3 e power 2x. So this is same, e power 2x you have to keep. So this is 3 by 4, 8, so 12 plus 3 is 15. E power 2x. This is nothing but 1 by 5 into e power 2x. So what is our final solution? Our final solution is y is equal to a e power minus 3x plus b e power minus x plus 1 by 5 e power 2x. 1 by 5 e power 2x. So 1 by 5 e power 2x is the particular integral, and d is also there, I think. So B is the answer here. B is the answer here. So similarly, if you look at the 10th question, that is similar one. So the degree of the differential equation, this is a straightforward question to the general solution of d square. So for this one, the answer is you have d square minus 1 is equal to 0. So d is equal to plus or minus 1. So there is here the correct answer is p e power x plus q e power minus x. Here the if it is d square y by dx square plus y is equal to 0, then the answer A is correct. Then the answer A is correct. If d square y by dx square minus y is equal to 0, then the answer is p e power minus x plus p e power q e power plus x. What I mean to say is that if we have d square minus 1 acting on y is equal to 0. For this one, what are the roots here? So here if you want auxiliary equation here, m square minus 1 is equal to 0. So m is plus or minus 1. So what will be the solution here? This being a homogeneous equation, the solution is y is equal to a e power x plus b e power minus x. On the other hand, if our equation is d square plus 1 acting on y is 0, then the auxiliary equation here is m square plus 1 is equal to 0. So m is equal to plus or minus, you have I, plus or minus I. M square is minus 1. So plus or minus square root of minus 1 is plus or minus I. So in this complex roots, so you have alpha as 0, beta as 1. Quotient of I, that is modulus of quotient of y is I, 1. So in such a case, you have the answer as y is equal to p, y is equal to p power 0x into, not p, e power 0x into p cos x plus q sin x. So you have p cos x plus q sin x. So for that, maybe it is plus there. So the answer is A. So if you look at 14, it's also a straightforward one. Real distinct roots means discriminant is greater than 0. So the answer is A. 15th one, the solution of the differential equation d square y by dx square is 0 with boundary conditions. So how can we do this one? D square y by dx square is 0. D square y by dx square is 0. D square y by dx square is 0. D square y by dx square is 0, we mean this implies you can write that y is equal to dy by dx plus some constant a. Again, if you integrate one more, I'm sorry. This implies so d square is, see, what is the auxiliary equation? You can in fact write like this also. Auxiliary equation, so this is d square y is 0. So what is A here? A is m square is equal to 0. So m is 0, 0. Twice, double root. M is 0, 0. So if that is the case, then what can we write? Y is double root e power 0 into x into a plus bx. So you have a plus bx here. Y is a plus bx. But there are boundary conditions here. What are they? Dy dx is 1 at x is equal to 0. Dy dx is 1 at x is equal to 1. Dy dx is 0 at x is equal to 1. Dy dx is 1 at x is equal to 1. Oh. So you have this curve is passing through 0, 1 as well as 1, 1. So here what we are saying is that x can be 0 or 1, but y is always 1, it says. y is always 1. So you have, okay, a is 1, a plus b, a plus b is also 1. So if a is 1, then b is 0. So we have a is 1, b is 0. That is the answer. So it is, okay, a constant, only a constant. So y is constant. That is the only answer. Y is 1. Y is 1. Y is 1. Y is 1 is the answer here. Y is 1. Yeah, it is there. A is the answer. Then we go for 16. The order of the differential equation here, order is 2. Highest order derivative. It is 2. So B is correct. Consider the following differential equation. So the numerical value of this is, so we need to find the general solution first and then do it. Okay. So you try this problem. The solution of the differential equation, this is also a similar one we have explained. This is also a simple one. You can try the next class. If you have any queries, you can bring. So this is what we have about second order differential equations. This is what we have about the second order differential equations. So we try this one. We can try this one. What is given here? What is given here? Yt plus y double dash t is 0. Yt plus y double dash t is 0. That is given. Okay. Then y dot 0 is 1. Y dot 0 is 1. Y dot 0, that is 1. And y0 is 2. Okay. Y0 is 2. So for this differential equation, how can we write in our notation? How can we write in our notation? One plus d square y is 0. So whenever dot is there, independent variable is considered to be t, or you can take x also, it's not an issue. So d square is minus 1 here. I mean auxiliary equation, if you want to be m square plus 1 is equal to 0. So this implies m is equal to plus or minus I. So our y is, our y is a cos x plus b sin x, right? Now see what he is doing. He is calculating y dot. Y dot means y dash. What is that? Is the meaning? Y dot is minus a sin x plus b cos x. B cos x. Now this is okay. If you put, see what is given here. Y dot 0 is 1. Y dot 0 is 1. So y dot 0 is 1 implies, y dot 0 is 1 implies 1 is equal to minus a sin 0 is 0 into 0 plus b into cos 0. Cos 0 is 1. Okay, y dot 0 is 1, we mean 1 is equal to 1. On the other hand, y0 is 2, that is also there. So y0 is 2. Y0 is 2, we mean a into cos 0. So a plus b into sin 0, it is 2. A is 2. So a is 2, b is 1. A is 2, b is 1. So what will be the final one? A is 2, b is 1. B is 1. A is 2, b is 1. So y is 2 cos x plus sin x. So that will be the answer. But he is asking for t greater than or equal to 0. For t is greater than or equal to 0, what he is asking? The maximum value. T greater than or equal to 0. So maximum value if you want, the answer will be, see, cos x will take maximum 1. Sin x will take maximum as, so if I take 0, you cannot take same, so it is 2. If you take 1, pi by 2, 1. So pi by 2. So the maximum value here is 2. Because cos x maximum value, see here, cos x maximum value is 1. Sin x maximum value is 1. But they both cannot attain the same x. So your max y is, maximum value of y will be 2. Maximum value of y will be 2. So B's answer is 2. So for example, 19th question, the answer is, wrong option. Root 5, he says. How can it be root 5? Okay. Root 5. See, how can we have root 5? Maximum minima values if you want to apply. What is y dash? Y dash is y dash is minus 2 sin x minus 2 sin x plus cos x. So y dash is 0 means what is the meaning of that? So you have 2 sin x is cos x. So we have tan x is 1 by 2. Tan x is 1 by 2. Tan x is 1 by 2 means you have only one solution. Tan x is 1 by 2 means you have only one solution. So it will be it will be, I think, 8 root 5. So fine, we'll stop.